All right, good morning, everyone. Um, let's get started here with our class today. Let me first start sharing my screen. Okay, so today we're going to continue and hopefully finish the yield editing exercise. So if you don't have anything open yet, I just want to show you again how I would do it. So I come here to our folder of this specific project, and I double click on that rproj for this project here. And something, I guess, this is a good time to remind you all is you can always launch any RStudio window if you just launch, like if you go on code and click on a QMD file or maybe RMD file, that would launch an RStudio window. However, most likely that window is not going to be the project that script is related to. So it's actually better if you're not going to be working with a given project to actually launch the project itself and then launch that that script inside of it instead of double clicking on the script as the first step. So I'm just launching that project here. This is, let me just do something. This is the way my project looks. And again, you're probably tired of hearing me saying this, but the way that you can check that you were able to launch that project is to look at the top right and see if the project name is there. If you double click on just a QMD file, it may launch an RStudio that is not your project. It's probably going to say preview none or project none, something like that, which we don't want, right? We always want to be in that right project. So launch the project. If you come here in the Files tab, you can click on the R button to go to the main folder of the project, go in the code folder, and then bring in or click on the Yield 17 editor partial. That's the one that we were working with last time. Let me increase my font size a little here. Okay, so just a quick refresh of what we did last class. We basically brought in the wrangled version of the yield data set, which means that it was already a GeoJSON file, which when we imported, it was imported as an SF object into R. And then we applied the yield, mean and maximum yield filters, and also this minimum maximum speed or velocity filters to it. And we already filtered out about 2,000 observations, and we checked to see how the summary statistics were changing as we made those different filters. Today, our goal is to apply a position filter. So for that to work, you may come. So here, if you look on the script outline, if you're not seeing, just toggle that on and off. If you come to the script outline, what we're starting off today is the yield editor position. So if you find that on your outline, you can click on that and takes you to that part of the script. And we've finished pretty much everything above it. If you want to go ahead and just click the run all above, so it's going to run everything up until this point. Let's try that just to make sure that we have all the proper objects. And I know that we were creating some interactive objects like before getting to this point. So if for some reason on your computer, interactive objects take some time to run or create, you may want to go chunk by chunk instead of doing run all and then skip those interactive ones. So for me, everything worked fine. So the last object that we created was called the EO17WSF. And again, the SF, I named it that way to mean that it was the speed filtered. And remembering that we applied the speed filter on top of the one that had already received the EO filter, right? So the speed filter has already received 2 or 4 filters, right? Min and max yield, min and max speed. Okay, before we continue, I just want to ask, does anyone need a little bit more time to be able to create the Yield 17 SF? Because we're going to be using that as we continue. So I can hold a little.
Yes, Professor.
Okay, I'm going to just wait a little bit then. So while I'm waiting for some of you to catch up, I just want to mention something. So today we're going to be applying the position filter using the field boundary. And for that, you should have, I think I don't know when was the last time that I updated GitHub, but I sent you all an email after that. It was, when I shared this script here that we're working on today. And at that time, I also in the class data, I think, or data folder on GitHub, I had a field boundary. So we're going to be using that here, and I asked you to basically copy that from GitHub and move into your data folder of this project. So if you have not done that yet, please go ahead and do while we hold on for a second. How's everything going, Athens? Were you able to catch up? Any news from Athens? Can we keep going? Sorry, if you said something, I didn't hear. Okay, let's just give it another minute here, and then I guess we'll have to keep moving. Yeah, so everyone just make sure that, on your data folder, if you browse that on your project, if you click on it, you do see that boundary.geojson there. They're going to be importing that. I guess while we wait, does anyone has any questions about what we've done, or maybe something's not clear? Any code, mistakes or errors happening? All right. Well, we're gonna have to keep going here. For those in Athens, sorry if this is not coming through for you. I wish I could help you more, but I guess we're gonna have to keep going, and you can always use the video later to catch up. Okay, so if you come here to the boundary chunk, we're gonna import the boundary first. That's the first step to do the position filter. And since the boundary is a GeoJSON file, as you can see, right? So it could have also been a shapefile, as we already talked about. Shapefile and GeoJSON serve the same purpose. We're not using shapefiles mostly because they have multiple accompanying files with the SHP file, and GeoJSON just one. So it's just, a little bit tidier on the data management side. But since we're bringing in a boundary file, so it's going to be a polygon. Let me ask someone, maybe in Tifton. I think Austin is in Tifton, right?
Yes, sir.
Hey, Austin, let me ask you something. So if we're bringing in a GeoJSON file, and because it is a GeoJSON, it is a vector file, a geospatial vector file, what is the read function you think we should use?
SF.
Yeah, that's right. Read SF. Thanks. Yeah, that's correct, right? So so let's come here and do a assignment symbol and do a read _SF. And just to, just to perhaps expand on this a little bit more, every time we bring in data into R, we use a read function. And then what type of read function depends on what data type we're bringing in, right? So if this was a CSV, we would have used a read CSV, which we're not using because it is a geospatial vector data. So because of that, as Austin said, we're using read SF, right? Because in R, SF is the package we're using to handle geospatial vector data. Okay, so open and close quotation marks. You say // to get outside of the code folder, hit tab, go inside the data folder, hit tab again, and then select the boundary.geojson. So if you run that, it should have popped up on your environment, and we can just go ahead and print it just to see how that looks like. So after printing, I'm coming here to the first panel that appears. It's telling me it is a multi-polygon. It gives me the bounding box, and it says it's already on a geodetic CRS. And so it's good that already has a CRS assigned to it, is WGS84. We will change that in a second here. And before we do that, I just want to show you again, if we go on the data panel here of the boundary object, we see there is only one row, and it just has a column called ID with a number 1 and then the geometry. And this is because this is just a boundary, right? So at this point, there is no data that is related to this boundary. It's just a boundary, right? So that's why we just see a very simple SF object with just one row of data. Okay, so if you come to the next chunk here where I left you the name already as boundary W, I want to have everything on the same CRS. And if you remember on the yield, we were using UTM NAD83 zone 16 north. So let's also change our boundary to that. Right, so we use the assignment symbol. We start with the object that is called boundary. We use a pipe. And if you recall, when the object already has a CRS and we want to change that to a different CRS, we use the function st_transform to transform that CRS. And then it has an argument called CRS. And then here we give the EPSG number of the CRS that we want to transform that into, which in our case is 6345. This is the EPSG for NAD83 UTM zone 16 north. So if we do that and you print it, the only difference now is that we can see that now is a projected CRS as we want it, right? So the UTM is projected, WGS is geographic. So that's the difference there. And now it's on the proper CRS that we needed. Okay, so if you come here to the next chunk now, I just want to visualize this boundary. So I already left you here if you remember in the beginning of this script, we developed this map here. You can just go ahead and run it. This is just a map, a yield map, a raw yield map, pretty much. And the reason why I just called this object and it printed the map already is because on one of the first chunks that we were doing plots, we did a ggplot plus geomsf, yield data, and all that, but we saved that into an object called yield map raw. So that's why I can just call that object here and the map appears. And because this object here is basically a ggplot map, we can just add a plus to it and just keep adding layers as we would normally with any ggplot. So to add this boundary here to this ggplot, let's go ahead and use geom_sf. We need to say data equals, and then boundary W, right? So remember, boundary W is the projected one. And let's just run it just to see what happens. So if we run this, it basically adds the boundary on top of the yield data because that's the sequence that we're giving it to ggplot. However, it's not very useful at this point because we cannot see the yield data behind it. So to overcome that, we can just come here and say fill equals NA. NA has to be uppercase. And then that basically removes the fill, but it keeps the boundary, right? So we can really see the boundary now in relation to the yield points. Okay, So one thing that is interesting here is on the paper that you read about the yield editor software and the different filters, they offered a couple different options to do the positional filter. One of them was to also use the quantiles, but then instead of using quantile on yield or speed, you would use that on the geographic coordinates of X and Y. While I think that is a valid option, I think I prefer the boundary option better because that is more clear cut, especially if you have a field that is not very, I guess, rectangular or, you know, in any direction. If it's not a very like an easy shape, not easy shape. I'm not coming up with the right wording for this, but if it's a field that has lots of like ins and outs and it's just a weird shape, then using a quantile approach to define the position filter for like a field that doesn't have a very easy to manage shape is not the best approach. I think that using the boundaries is a better approach, especially for those types of fields. And again, the yield editor was developed by, you know, researchers in the Midwest, and in the Midwest, farms are very much like rectangular or quadrangular. They're very, very easy to apply the positional filter based on the box plot and make sense. Oh, sorry, not box plot, on the quantiles and make sense. You know, here in Georgia and perhaps in other states in the Southeast, fields are not as well, you know, they're not as rectangular, right? As this one here we can see, but there are others that are even more different shapes. And so I think that I guess saying all that just to tell you why we're using the boundary for the positional filter and how that's probably a better option for the types of fields and field shapes that we see in Georgia. Okay, so we have the boundary, right? And now what we want to do is basically shrink this boundary to some extent and then remove all points that overlap with that shrinked boundary, right? So every time you want to either shrink or expand on a boundary or even a point, in GIS language that is referred to as doing a buffer, right? So next step we're going to do here is do a buffer, and in this case has to be a negative buffer because we're moving inwards instead of outwards. So we're going to do a negative buffer next. So if you come here to the next chunk, I left you the object name as buffer. We're going to use the assignment symbol. We're going to start off with the object with our boundary object, so boundary W, and then add a pipe, hit return, and use this function called st_buffer. So this function here has an argument called dist, which is the distance. And we're going to say -20. So again, negative because we're going inwards, and 20 here. So this value is on the same unit as distance is measured on the incoming data set. Because our incoming data set here is projected, this 20 is, so it's projected in meters, so UTM is in meters. This number here is 20 meters. However, and something to be very cautious, if you do a buffer on a geospatial object that is geographic, so it is in angles and not meters, as WGS84 is, if you say -20 and that is WGS, then it's -20 degrees, which is a whole lot of a mess and definitely not going to get you what you want. Just keep that in mind. When we're doing distance-based operations, always make sure your objects are projected and not geographic in a geographic CRS. Okay, so if you run that and you print it, yes.
So that negative on 20, is it like a standard approach, or is because of this data, or is where do we come with -20 meter buffer?
That's a great question. Was that Dennis?
Yes.
Awesome, thanks, Dennis. That's a great question. I actually meant to talk about it, but I guess I forgot. So -20 here is going to be really, really arbitrary, to tell the truth. I'm sure we could come up with some formula to say, oh, like the distance on the x-axis, and some formula that we could use the distances themselves of the field to decide. But in this case, it's kind of arbitrary, but it's not completely arbitrary. And I'm gonna show you next when we plot this buffer how I decided -20. But this -20 is not fixed, right? It could have been -10, it could have been -50 or 100. It kind of depends on the field size, and also because the goal here is that we exclude the outer points, right? So the points are really close to the boundary. That's what we want to do. And so, of course, if when you draw the boundary of the field, if your boundary is really far from the points, you're gonna have to do a larger distance to at least encompass some of the points of the field, right? So imagine if this boundary, instead of being right where it is, if you were like out here, right? A -20 buffer would not touch any points. So it kind of depends on that as well. And is a little bit of a personal judgment, but the goal is to remove some of the outer points that are sitting on the boundary of the field. And that -20 does it for this case. Thanks for the question. Okay, so if you come to, let's now plot this buffer and see how that looks like. And kind of going back to the question that Dennis had, is see if that -20 makes sense for this field or not. So I left you the code that we produced on the previous chunk already. So this is basically, if I run this at this point, it's just that EL map with the boundary. What I want to do now is add a plus here, hit return, add another geom_sf, right? So I want to plot now the buffer. So we're going to say data equals buffer. We're also going to remove, the fill so we can see through it. So we're going to say fill equals NA. And I also want to give it a different color. So a color of the outline, I want to have orange. So color equals, open and close quotation marks, orange. So if we plot this now, we're going to be able to see where that is sitting, right? So now if we compare, the buffer is more inwards than the boundary. That makes sense, right? That just confirms our negative buffer. If it were +20, then the orange would be outside of the black. It's -20, so it goes inward. And we see that it is removing some of those boundary points. So again, if our original boundary was like farther away from the points, maybe we would have had to use like -50 just so the buffer would move a little bit more inwards and touch at least some of the points near the boundary. That's kind of how I decided here, but it's pretty much subjective. Does that clear a little bit, Dennis?
Yeah, but when I look at the buffer, that orange one, still I feel like there are some protrusions of the features from the image.
So you're saying that like there are some places that we're not getting the points. Is that what you're saying?
Yeah, like on the south. Yeah.
I mean, there's some places where the buffer is not touching, right? But it's just because of that shape of like different passes. And you're right. I mean, we could have done a different size buffer here. It could have been 25. So yeah, it is subjective to that extent. Okay, so now we created our buffer, which is what we're going to use to do the filter. However, now we're gonna I'm gonna show you a different concept. So up until now, we were filtering based on data values, right? If it was larger or lower than or greater than a certain threshold, we were keeping it. And because we were doing that type of filter, we were using the filter function for that. However, here, now our position filter is actually based on position, right? And although perhaps there is a way that we could come up with a way of saying, if if the value on the x-axis and the y-axis is greater or lower than this, then keep or remove. but that would just be a lot of work, and we don't actually need to do all that. There is a function. So if you come here to the next chunk, where I'm calling this object EO17WPF for position filter, we start here with our previous speed filter dataset, which was the EO17 underscore W underscore SF for speed filter. Add a pipe, and in the past, I mean, the previous filters, we're using a filter position here, right? Now, again, because it is a geospatial data, there is an easier way of doing that, of saying any points inside of the orange, you keep, any points outside of the orange, you remove. So that is a function called st underscore intersection. Make sure you get the right function. There is one that's called intersects. That's not what we want. We want st intersection. And then we just give now the object that we're trying to intersect with yield, which is buffer, right? So if you do this, and we printed, we see now that we lost maybe, I don't know, 300 or so observations. So before EODS, I'm gonna print EODSF just so we see how many rows we had. We had, well, yeah, we had 28, I mean, almost 29,000. So now applying the position filter, we have, you know, almost 28,000. So we actually filtered out about 1,000 observations as well. And again, everything that is outside of the orange was left out on this filter. Okay. So we can, I guess, you know, I'm just thinking here, I don't think I actually plotted the data for us in the script. You know, let's just kind of do that on the fly. I didn't have that. So if you just come below, well, sorry, maybe after the filtering position. If you come after the filtering position, give a few returns, you can click on that +C button to create a chunk. So it just creates a new chunk here for us. Let's just do a quick map here. So let's start with ggplot. We add a plus, we do a geom underscore SF. I want to say data equals this object that we created above here. So yield 17 WPF. Well, let's just try to plot that as that and see how that comes out. So we're not saying fill equals yield at this point because, you know, I'm just trying to see about the filter, the position filter. I just want to come here, add a plus, add another geom underscore SF. And I want to add the buffer. And if you recall, we have to say fill equals NA so we can see through. And I just want to add color equals orange again, just so we can confirm that the filter actually did what we were expecting. Yeah, it did. It kind of looks like it didn't, but that's an artifact of the size of the points, of the yield points. So if we just change this, let's do size equals 0.1 on the second GeoMSF that we did there. So we confirm that really all the points were within the orange outline, right? And also, you know, something cool to notice here is we already have these gaps in the data, and those are basically points that were removed by the previous filters that we can see here. That we don't see those gaps if you're on our EOD raw map, right? We don't have those gaps. On our EOD filter, we have those gaps and also nothing going beyond the boundary. All right. And just to, well, I guess I'm just going to do just to not make things confusing, but if we wanted to color our yield points by yield, we would have just used the aesthetics function and said, I think we were using fill, and this was yield. What was the variable? Yield. Oh, let me just bring that quickly here so we see. We were doing yield pounds per acre. And actually was not, shouldn't be fill, should be color. And again, this is just the native or default color scheme that ggplot gives us. I think here on top we were using Viridis. So if we want to just make sure that that changes as well, we could have used scale underscore color underscore Viridis B for bint, and then add a plus. Yeah, so this kind of looks like more what we were doing before, and we can really see how all three, we can see here the results, the geospatial results of applying all the 5 filters we did, right? So those holes in the field are because those points were removed by any of the filters. All right. So if we come next here and we just check a summary, after applying the position filter, we see that the minimum still remains at 204. The maximum, I think, still remains at where it was. And I think the
Dr.
median,
President,
yes.
Can you scroll up just a click right there?
Yeah.
We're a little slow on the typing down here.
Sorry, just let me mute Athens so I can hear. Okay, can you say that again?
So, all right, we're just dragging behind you on typing.
Oh, yeah, no, absolutely. Yeah, sorry. I know I tend to type fast, and yeah. So yeah, I mean, really, anyone, if I'm going too fast, you're not able to follow along, just let me know. And
I got an incomplete expression, and it says it looks like a unmatched open bracket is, I don't know if I. Oh,
okay, so
that means I didn't close it. Yeah, that's me right there.
yeah, so anytime that like if we forget commas, parentheses, quotation marks, one way to help you to find where that is if you look on the side here. Well, let me do on my side. So if I forgot this one here, it gives you this axis on the lines that it thinks the error can be. In this case here, it was actually, the error was actually here. It was missing something here. But yeah, you can look for those axes because they may give you some more details of where the error could have happened. All right, can we keep moving?
Yes, sir. We're good here, I think.
All right. Okay. So we checked the summary here. Now what I want to do and really have us thinking through this is I want to create summary. So statistical summaries with the number of observations, the minimum, mean, the maximum, standard deviation, and coefficient of variation for both the raw data and the filter data. So now the filter data, just to refresh your head, we applied 5 filters, right? So we applied minimum, maximum yield, minimum, maximum speed, and position. So the first thing then that I want to do in this next chunk is to create the summary for the raw data. So I left you the name of the object that we want to save this result into. You just add the assign symbol. We're starting with a data set. So because we're first doing a summary of the raw data, the data coming in for this that we want to use is yield 17W. That's the raw data, right? Before we apply any filters, we add a pipe, hit return, and we're going to call the function summarize. Just as we did in the past with the group by summarize, the difference is if you use a summarize without a group by, it's going to summarize for the entire data set and not separate between groups that we establish in the group by level. So we're not specifying group by here. We're going to summarize for the entire data set. That's why we're just going straight into summarize. So the first thing that I want to do here is say n. So n is for like number of observations. This is the name of the column. I want to say n equals, and the function that we use to get number of observations is called length, because it's going to give us the length of a given variable in number of rows. And we need to say which column of the data set we want to get the length of. So if I just print yield17W, it has a whole bunch of columns. I am specifying that I want the length of yield pounds per acre. Okay. Now, I don't want just number of observations. I want a whole bunch of other things. So we can just keep inside the same summarize, add a comma after the closing parentheses of the length, and hit return. You can hit return a couple of times just to have the closing parentheses of summarize in the end, and we can work in between here. So the next thing, I want the minimum. So I want to call that column min. I say min equals, and then the function for that, as you already know, is also called min, but then make sure you open and close parentheses. And again, we're going to say minimum of yield pounds per acre. Add a comma, hit return. We're going to do the same with mean. So I want to call this next column mean equals the function mean of yield pounds per acre. Add a comma, hit return. Next thing I want to do is calculate the maximum. So I'm going to call this column max. I say max equals, there's a function also called max of yield pounds per acre. Add a comma, hit return. We want to do standard deviation next. I want to call that ST. There's also a function with the same name. So as the ST here is the name of the column, but I want to also call a function called ST and give it the yield pounds per acre. And lastly, I want to calculate coefficient of variation. So add a comma here, hit return. We're going to say we're going to call this column CV for coefficient of variation. And R does not have a native function for CV. So there's no CV function like that, or maybe there is. Maybe it's a new one. But anyways, when I prepared this script, there was not a function called a CV. So we kind of have to type that CV formula, which is basically just, so you can go ahead, open and close quotation marks here, because and go inside the quotation marks, or sorry, not quotation marks, the parentheses. And the formula for coefficient of variation is standard deviation divided by mean. And we can call SD and mean here because we already created those columns above. If we first did CV as the first line of code here before we created SD and mean columns, this will not work. So it works here. And the reason why I asked you to have that inside of the parentheses is because now if you go outside the parentheses, we want to multiply that by 100, so we get a percentage. So if we did not have the parentheses, sometimes it can be tricky because it will multiply mean by 100 and then have SD divided by that, which is not what we want. We want first the division and then the multiplication. Okay, so if you run this and you print it, we have all of our columns that we asked to calculate. However, I want to do a couple of things here on this pipe workflow before we move to the next chunk. I want to have a column here to say that this data was the raw data. Right now, we don't have anything saying data equals raw. I want to do that. And I also want to remove this geometry here. So the geometry is here because the incoming data set was SF and it had a geometry column. But now it doesn't make sense anymore to have the geometry column here because this is just a data set. We're not going to be plotting this as a map. So I want to add a pipe at the end, after the closing parentheses of the summarize, hit return. And I want to create a new column called data equals raw. To do that, we're going to use the mutate function. I want to call this new column as data, and I want to say equals, open and close quotation marks, raw. So if we do this, I just want to run and print for you to see. Now the last column here, it says data raw. And I also now want to remove this geometry here. So add a pipe after the mutate raw. We're going to use the select function from the dplyr package. So as you already know, we do dplyr : select to make sure that it's coming from that package. I want to actually first select the data column. So I want to move that to the first position of this object. So I say data. And then we're just going to select, well, there's a function called everything that selects all the other columns. So let's just do that so you see what happens. So now we basically move data here to the first position, and then we have everything else, including the geometry, which, you know, I guess that's fine. We can leave it there, even though we're not going to be plotting it. Okay, so now if we look at the summary here, I just want to show the code if you're still catching up. But so the number of observations of the incoming data set was almost 32,000. You had a minimum of 0, a maximum of like above 4,000 pounds. And this is on yield in pounds per acre, right? So all these values are related to yield in pounds per acre. So a maximum of over 4,000, which we already talked about, is not very, it's not a very plausible number. Our mean was 1,150, and we had a very large standard deviation of above 400, and our CV was almost 36%. So highly variable data. Okay, so if you go to the next chunk, I basically left you here most of the code. So I already left you all the code of what we just did above. I just left, the only thing you're gonna have to change is the 3 dots here, because now this is the summary of the clean data set. So if you just remove the 3 dots, and we're gonna call the clean data set, which is named yield 17 underscore W.
Sorry, Professor.
Yes.
Did we remove the sorry, geometry column? Did we remove that?
We did not remove at that point. Yeah, we just left it there for now.
We're not going to do that.
Yeah, we're not going to use it, but I guess so. Yeah, I guess for now we can leave it, because I was just thinking here of how I planned the class, and I actually left it there. We could have also removed, but I guess just to keep track with the complete script that you're going to get afterwards, we can just leave that.
All right.
Yeah. Okay, so here on the clean yield summary, again, make sure you remove those 3 dots and you replace that by yield 17 W PF, and PF is for position filter, which is the one that had all the filters applied to it, and the last one was the position. Also, a difference here is that we're calling this data equals clean, right? So if you just replace that data there and run it, it should run all right. And if you print it, it should say data clean, and then, you know, number of observations and all the same things that we calculated previously, we also calculated here for the filter version. Okay, so if we come to the next chunk here, what I basically am doing is I'm starting with the summary raw, so the object that we created above with the summary for the raw data, and I'm binding rows. What does that mean? It means I have 2 data sets, right? So the summary raw and the summary filtered, and I want to basically have them below each other. To do that, we can use this function called bind rows, and it only works if all the column names in both data sets match. If you have a different column name, if you have more columns or less columns in different data sets, the bind rows doesn't work. It has to really match the column names for this to work. But in our case, it does match, because that's how we built them. So if you just run that, here we have both summaries together. The first row is for the raw data, the second row is for the clean data. And then we can really like visualize the effect of the filters, right? So we basically lost here about 4,000 data rows by applying the filters. The minimum went from 0 to 204 on the filter version. The mean went up on the clean version compared to the raw data. The maximum decreased to a more reasonable value. Standard deviation also decreased, and CV went from about 36 to 27%. Right, so these are some of the metrics that you also saw reported on the paper, and you saw and one of the assignment questions was what happened after applying all the filters on that paper. Here we can have a similar idea of what happened with our data after applying all these filters. Okay, so another way of comparing this is by using, so if you just go ahead and run the next chunk, this is basically the geom density. So it's the density, the distribution of the data, and this is it for the yield 17W, which is the raw data, right? What I want to do next here for us to visualize is to add another geom density, but for the filter data, so we can see how different that looks. So what you can basically do is just copy this geom density here. We're gonna just be editing for adding the next density. You can add a plus after that geom density and just paste what you copied. So one thing that we have to change is the data coming in, right? So this has to be the WPF. The column remains the same. I just want to change the color, the fill color to yellow instead of blue. Okay, so I copied and pasted the geom density above. I changed the data coming in and the color from blue to yellow. So if you run this, now it's plotting both of the densities together, where the blue is the raw data and the yellow is the clean data. What we can see here is basically most of the difference between them is on the lower end of the distribution, where the raw data had a lot of points near zero, and now the clean data basically doesn't have those points. Those points were filtered out, and because of that, then the mean here, or the peak, is higher, right? Because this is just concentrating more data points around the mean. So that's why the peak is higher for the clean version compared to the raw version. Okay. So up until this point, we have compared. I think this is a good stopping point for today. So today we finished applying the position filter. We brought in the boundary, create a negative buffer, and filter out everything that was outside of the buffer. Then we created some summaries to compare raw and clean data. So we did a table summary, right? So with the number of observations, minimum, mean, maximum, SD, and CV. And we also did a graphical assessment of that using the distribution of the data, comparing both of them. Now, the last way of comparing them and also the most fun, I guess, is by making maps, right? I think we can leave that for Monday, because we're going to start here. So we're going to be doing both static and interactive maps to compare our raw and clean data sets. And I just want to stop here. I think is a good stopping point. But before you all go, hold on a second, because I've not been great about taking attendance during class because I keep forgetting, but I want to do that more. So let me create an issue here for today's attendance. So February 10th attendance. Okay, I just submitted the issue. If you were following class live today, please go ahead and respond to that issue. I will, just to let you all know, when I do open the issue in class, I will close it as well and not take in any more answers afterwards. So please make sure you respond to attendance until 10:05. So we have like 7 minutes, and I will close the issue after that and not take it in attendance after that point. Okay, so while you're all responding on attendance, does anyone have any questions about what we did today, or code questions, philosophical questions, anything?
I had a question about the mini project.
Okay, yes, and who is that?
Miller.
Okay, go ahead, Miller.
So we were trying to kind of filter out the minimum and maximum values like we did in that yield. It was the big one that we did in class.
Mm-hmm.
And whenever we try to select and run the copy and pasted code from the class activity, it's not giving us, it's cutting off at 1,000 pounds. It's not letting us look at the whole data set.
Interesting. I mean, from what you're describing, it's hard for me to kind of pinpoint what's going on. if you can like open an issue on GitHub and perhaps like, you know, copy and paste or take a screenshot of the code and the output, maybe that will help me to at least understand if there's something in the code. And it may be more complicated than that. You know, maybe we're gonna have to connect by Zoom to really troubleshoot it. But yeah, I guess for now I don't have a good hypothesis of what could be happening.
Yes, sir.
Yeah, and also, you know, I just wanted to comment here that so as you all know, the deadline to submit the mini project is next Friday, so a week from today. I do anticipate that you all run into different issues and maybe things we didn't see in class, because you're all working with different data sets, and I did not, on my side, get to work with all of the individual data sets yet. So if you do run into something weird, do reach out, because that could happen, is somewhat expected, you know, as we're all working with different data sets. So do reach out if you come across something weird, and I definitely want to make sure that you are on the right path, right? My goal here is that you all successfully complete the mini project. So
Dr. Bastos,
yes.
I have like not related to this, like, but the accuracy of like, this combined data. So like, if we got the field data, it's like we go and weigh the overall corn harvest from a particular field. And how much accuracy is this, like combined data, because we are removing some of the data points. So what will be the overall accuracy of this whole data if we consider it as a whole as a field?
You mean what's the accuracy of the yield of the yield data itself?
Yeah, like, so we harvested a corn in the field and we took that truck to the weighing balance and we weighed. And we know that this much is we got harvested from the field. So, and we then compare the data with our yield monitor data.
Yeah, I see what you're saying. Yeah, so that is actually, so here's the thing, right? So yield editor data contain errors that we know happen for sure. But even after filtering it, it doesn't mean so we filter potential errors, but it still doesn't mean the data is good data, right? So this all can come back to like properly calibrating your monitor data, making sure you're checking things, and you know that the person that's doing the harvest is following some guidelines to optimize the quality of the data as well. And of course, like that varies a lot from person to person, from combine to combine. And so it's really the only way of really like ground truthing the data is, one of them is doing what you're saying, Amrinder. Like let's say if you have a producer field and you know they are going to harvest with the yield monitor, with a combine that has yield monitor, and you go there and take a whole bunch of hand samples within given areas, right? And then you know more precisely what is the yield at that point. You can compare that later with a yield map and see how well they match. Of course, they're not going to match perfectly, but that's one way of checking. Another way of checking is like, if you know, that is a very laborious thing to do, to go out and take a whole bunch of grain samples for yield in the field by hand. So another way that you can also do this calibration, or not calibration, but at least understanding how far off it is once the combine harvest one pass, you just get the weight of that pass, and then you know how much area you traveled, and so you can just compare on a weight basis how much the yield monitor data is telling you that you had in that entire pass, and how much actually was measured at the end. So that's another coarser way of doing it.
So it's recommended to do the calibration every time we use combine, because I have no experience with these things. That's what I'm asking.
So your question is if
So
the
did the
combine should
farmer
be
calibrate before every use, or they just go every time as it is?
Well, I mean, they should calibrate at least like before they start harvesting. And to tell the truth, I don't really know what's the proper recommendation of how frequently they should be recalibrating. But I think the issue is that normally the producers don't have the time to calibrate anyways. And has anyone worked more with yield monitor data and growers that would have like a more experience in maybe weighing in this discussion?
Yeah, technically for like cotton harvesting, anytime you change varieties, you should recalibrate. With grain, it should be the same way, but that's typically not done quite as often, just because it is an actual weight that it is calculating instead of a with the cotton yield monitors, it's a microwave like flow sensor, but with the grain, it's an actual weight. So the newer combines actually calibrate on the go. So there's much easier calibration practices for that. But cotton pickers should be calibrated pretty much every time they change varieties, but they're not.
Awesome. Thanks, Matt. Thanks for weighing in. Yeah, that's a really good point for discussion as far as like, you know, and one of the things that I was speaking with Matt's advisor, Dr. Verk, and we're talking about this as far as if there's a way that after the fact, like if a field was harvested and the monitor was not calibrated, if there's a way that we can handle that after the fact with some of these techniques, but also other techniques as well. So it's definitely an interesting topic to explore. Yeah.
Okay, thank you, Dr. Westhoff.
All right. Thanks, Arminder. Thanks, Matt, for chiming in as well. So we are at 10:06. I don't want to keep you all for longer. So we're just past 10:05, right? So I'm going to close this issue and not take in any more attendance. Make sure that you claim your attendance if you were watching live. And I guess next class on Monday, we're going to finish the yield editor comparing the maps. And then we'll get started with some interpolation methods at that point. Thanks, everyone. Let me know if you have any issues, and I'll see you on Monday.